Hello, welcome to week 9 of CSM. In this video, I will be going over the first question of the linked list portion of the worksheet. So yeah, this is going to be a what would Python output type of problem, so let's get started. Alright, so what we have here is we have a variable a being assigned to a linked list of 1, 2, and 3. What this would look like if you were to draw a box and pointer diagram would look like we'd have one linked list with its first attribute being 1, the rest being a pointer to the other linked list, and and that rest of that linked list being a pointer to 3, and then an empty list. Okay, so if we try to call a dot first, it looks at the very first thing, first value, and it would output 1. And actually, to make this more clear, I'll put it down here. And remember that if you were to draw like an environment diagram type thing, this would be what it would look like. So yeah, that would come in handy in the future. So yeah, now we reassign a dot first to be 5. That is essentially just replacing this 1 with a 5. And so when we call a dot first, we'll get 5. And if we call a dot rest dot first, we would be referring to this rest of the linked list. And then we notice that it's pointing to the second linked list object, and that first attribute is going to be a 2. So this will return 2. Now we have a dot rest dot rest dot rest dot rest dot first. So if you were to just try to follow this using the diagram, bring it closer, we get a dot rest, which was this, and then we get the rest of whatever this is pointing to. So this is the second rest, and then we get the third rest of whatever it's pointing to, and then we try to call this fourth rest, and we notice that we can't really call dot rest on an empty linked list because it doesn't have one. So this would actually just output an error. Cool, okay. Now we have a dot rest dot rest dot rest equals a. This might trip you up a little bit, no worries. It is very useful to like realize what pointers are being pointed to. So if we look at a dot rest dot rest dot rest, a dot rest, and then that rest, and then that rest, we'd be looking at this empty linked list, and we want to reassign it to be a. And what exactly is a? A is just going to be this pointer to the beginning of the linked list. So that's exactly what we're going to do. We're just going to copy that pointer and have it also be pointing to this beginning link object. So with that being said, this does create a cycle. So when we call a dot rest dot rest dot rest dot rest dot first again, this would actually allow us to get a value. And if we were to follow it, this would be a dot rest, get a dot rest, a dot rest, and then a dot rest. The first value of this link object is going to be 2, and that's exactly what it returns. Okay, now we get into the repr and stir functions and stuff, and this might trip you guys up a little bit, but no worries, we'll go through it together. Okay. If we were to take a look at the repr method, you might notice that the function resembles that of a recursive function. This is because of like the if else return. Yeah, and like how, yeah, that stuff. Yeah. So if you were to call repr on this link object of 1, 2, 3. Ooh, a lot of okay. We check to see if self.rest is not link.empty. So if it isn't empty, you want to do rest repr being set to comma repr self.rest, right? And what that does, since we start off with a link object of like, I'll write it down here. I'll write it down here. 1, 2, 3, right? We call on this object as a whole, we want to check if self.rest is not link.empty, and since this is actually pointing to a linked list, and we call repr on it later on in the method, it kind of goes into that recursive loop until it does find that self.rest with a link.empty. And so we go into this repr function for self.rest, which is this, and we keep going until the very end, because this last link object will have a dot rest that is a link empty. And so in that case, we can finally go to this part of the code where rest repr is just an empty string, and then it actually just returns this string with link parentheses plus the repr of an integer plus rest repr and a parentheses. So what that would look like for the first for the end of the recursive call, I guess, it would look like link parentheses and then the repr of the first value of this part of the linked list. So we get 3 and I think, yeah, and parentheses like that, right? This would get returned into the previous recursive call, and if you were to keep doing this, it would eventually just look like rest wrapper would then be to make this clearer, I guess, that was at the very end of the recursive call of here, and now that we've finished with this, we can finally move on to repr being called on this part of the linked list. So self.rest in this case, so rest repr in this case is going to be a comma plus the repr of self.rest, which we have just processed, and that's the link in parentheses 3 in quotes, or yeah, in quotes. So yeah, now that we have that set, we can skip to this return statement, and then also concatenate it with link front parentheses repr self.first plus rest repr end parentheses. And so if we concatenate it, we extend this list. That would look like link parentheses 2 and comma and then end parentheses, and then rest repr and then end parentheses. And this would still be a string, because if we call repr directly on an object, it returns whatever it is meant to return, just with the quotations and stuff. So yeah, we're not done just yet. Now we go to the technically first but last recursive part of the question, and that would eventually just be this. That. And now we have rest repr, comma, plus repr of self.rest, which in this case now is what we currently have as our answer. Skip to this call, and we have link, open parentheses, or front parentheses, plus repr of self.first, which is going to be 1, plus rest repr, plus end parentheses, if that makes sense. So yeah, we continue to concatenate the string that we already have to be link 1, comma, yes, comma, parentheses. And again, this would all just be in a string, or in a quotes. Yeah. So that's how we would go about doing the repr function. And if you were to just call the object itself and put it in code as the object itself and press enter on the code, it would actually just invoke the repr method, and we'd get the same return value just without quotes. Cool. Okay. Now we have the stir method. Similar to the repr method, this will also be in quotes. So yeah. Now let's get to the stir method. This time, be careful. This is a different link object. This is a different linked list object than before, because now we have this like nope, not just yet. My bad. That's in this question. But yeah, keep in mind for this last part that it is different than these previous lines. Okay, so now we have stir, linked list 1, 2, 3. This time it's going to be in like done iteratively and not through a recursive call. So yeah, we want to start out with string being this less than sign. Don't forget the quotes. And now we go through the linked list. So while self.rest is not link.empty, we want to just concatenate to the string the self.first, the stir representation of self.first, which is just an integer, and that just converts it to a string, plus a space. And then we set self to be self.rest. Yeah, I should probably just point out what we're doing here. So we're checking to see if this value isn't empty. If it's not, we want to continue with the while loop, and we want to add to this string the first value of what we have so far, so just 1, and then add a space. And then we initialize, or we reset self to be self.rest, which in this case is going to be the start of this linked list, and then it just continues the while loop. And that will look like that 1, there's no commas, goes through the while loop again, gets the first value. 2, goes through the while loop again, no, it actually doesn't go through the while loop for this last link object, because self.rest is actually going to be empty, and so we just end by returning the string like what we have so far, plus the first value of the last link object that we stopped at, and the final like greater than symbol. So yeah, that would look like 1, 2, 3, that, and in quotes. Okay. So now we have to deal with print. If you don't know, print is exactly what the stir method is, except that when it returns it, it just returns it without the quotation marks again. So yeah. So this time we have a link object with a linked list as the first value of the object. And so if we were to do it, what this would return, we're going to start with the string again, and while self.rest is not link.empty, we want to continue the string. And you might notice that when we call the stir method on self.first, because self.first is a linked list object and we're calling stir on it, we want to go through this entire process again. And so what ends up happening is that we have these 2 bracket thingies at the very beginning, and then we carry on as normal. Notice how this is only a linked list object of 1, and so that would technically just look like, let's just erase this part. That would just look like that would just look like this. And so because self.rest is link empty, it'll just concatenate the first like caret thing that we have plus the value of the first attribute plus the end greater than symbol. And so that would look like 1, right? And after that we can carry on with the original like stir method that the print calls. And so now we can do the same thing as before, and so this will look like 1, and then 2, 3, and then close bracket. Yeah. If you're confused with how we got here, we just followed the same method as the stir, since print invokes stir as well, the stir method. And yeah, and we just go through it iteratively until we reach the end of, until we reach a linked list with link.empty, and then we cancel out of the while loop, and then just return whatever we have. So yeah, that would be question 1 of this whole linked list stuff. And yeah, thanks.